Hello everyone, I am Anik Tahabilder and this is my second paper presentation for the course Seminar on Database Management, and the paper title today is A Survey of Blockchain from the Perspectives of Applications, Challenges and Opportunities. This paper is authored by Ahmed Afif Manrat, Olav Skillen and Carl Anderson. And here's the outline of the presentation. First, I will talk about the blockchain architecture, then the consensus procedure, blockchain application. I will also talk about some challenges and future of blockchain technology. Then I will include my talk with my comments about this work. So first, the blockchain architecture. In blockchain, a node initiates a transactions in a decentralized blockchain network by employing a digital signature using private key cryptography. So a transaction can be considered as a data structure that represents transfer of digital assets between peers on the blockchain network. All the transactions are stored in a unconfirmed transactions pool, and then it propagates through the network using a protocol which is known gossip protocol, and then the peers need to validate those transactions based on some preset criteria. So for example, if the nodes try to verify and validate these transactions by checking whether an initiator has sufficient balance to trigger the transaction, or by trying to fool the system by enforcing double spending, and double spending refers to use the same input amount for two or more different transactions. So on the transactions is verified and validated by the miners, so then the block is included in the main chain. So here is a blockchain transaction procedure. So first someone initialize a transaction, as you can see in the image, and then the requested transaction is broadcasted to the decentralized peer-to-peer network, which is consisting of several nodes, as we can see in the images. And then the miner can verify the transaction. Upon verification, a new block is created, and then we need consensus procedure, that is the agreement among all the networks, and when that is confirmed, then this block is added into the chain. So now the block structure. So we have just learned that the data is stored as a block. So the block comprises the sequences of block, and the blockchain comprises the sequences of block which stores the information of all the transactions, and this procedure is very similar to a public ledger. These blocks are linked to each other via a reference hash that belongs to the previous block, known as the parent block. So we can see that from the image. So here is the block on, so which is referring, the hash of this block is referring to the earlier block, and the first block which is created is called Genesis block, and the starting block is called Genesis, and which does not have any parent block. A block consists of the block header and the block body. So we can see that every block has header. The header consists some meta information, and the body consists the transaction information. Now the block header attributes. The block header includes metadata such as block version, parents block hash, Merkle tree root hash, timestamp, n bits, and nonce as shown in table 1. So here we can see what does the block header attributes keeps. So the block version, then the previous block hash, Merkle tree, as we have mentioned here. So this information will be kept in the block header. So now we'll see the characteristics of blockchain. So the most important characteristics of blockchain are decentralization and persistency and anonymity and auditability. So the decentralization requires trust, which is the main issue, along with the lived reliances, availability and failover. So where the decentralization peer-to-peer block architecture could be a better solution. And the persistency is all the blocks are linked and connected with each other, so each block has a reference to earlier block. So when a lot of blocks are added on top of another, then it becomes very difficult to make any kind of modification in the block. So that's why this blockchain is persistent. The anonymity. So it is possible to interact with the blockchain with a randomly generated address. So a user can have many addresses within a blockchain network to avoid the exposure of his identity. So that means a user can be anonymous in a blockchain network. Then auditability. So all the transactions that occur in a blockchain network are recorded by a digital distributed ledger. So that's why auditing is possible with a digital timestamp. So here are some taxonomy of blockchain. So that includes the consensus determinations, read permission, immutability, efficiency, and centralized. So all these top four are common terminologies. So the centralized means the significant differences among three types of blockchain. So there are three major types of blockchain. So they are called the public blockchain, which is decentralized, and the consortium blockchain, which is partially centralized, and the private blockchain, which is controlled by a central authority. And we'll talk about all this in some later slides. Comparison of blockchain architecture. So there are three types of blockchain, which is public, private, and consortium, and this system can be compared using different perspective as described in the table on the right. So we can see among the properties there are nature, and there are participant, read write permission, and immutability, efficiency, scalability, energy consumptions. So based on all these we have categorized the blockchain, and we can see there are public, consortium, and private. So consortium is in between public and private, and it is possible to have some private blockchain which is controlled by any organization. In that case, the access in the blockchain is restricted among very specific people of that organization. So now the consensus procedure. In blockchain, how to read consensus among the untrustworthy nodes is a transformation of the Byzantine general problem. So in the BG problem, a group of generals who command a portion of the Byzantine army circle in the city. The attack would fail if one part of the generals attack in the city, and the general needs to communicate to each other on an agreement whether they will attack or not. So there might be a traitor within the generals. The traitor could send different decisions to different generals. This is a trustless environment. So how to reach a consensus in such an environment is very challenging. So this is a challenge for blockchain technology too. In blockchain, there is no central node that ensures ledgers on distributed nodes are all the same. Nodes need not to trust other node. So thus some protocols are needed to ensure that the ledgers in different nodes are same or consistent. So on such a procedure is called proof of work. So proof of work is a proof-based consensus algorithm. The basic concept of the consensus technology is to identify and determine the node that will obtain the right to be added into the blockchain by providing sufficient proof of its effort. As a matter of fact, that confusion will arise in every node tries to broadcast their block containing similar verified transactions. So moreover, the ledger will be meaningless if the transactions are duplicated in different blocks. So in figure 3 we can see such a proof of work procedure. So we can see that the transaction is added and then it can be rejected or it can be valid. So if it is valid, then it goes into the pool of unconfirmed transaction, and then select set of transactions to create the block, and then this problem is solved by computational puzzle solving, and a solved block and then verified and with a consensus and then added to the chain of the block. So then with this procedure there is a problem that is called block forking. So it is possible to envision a scenario where more than one miner finds the suitable nonce for the puzzle. So nonce is one kind of solution for the proof of work, and almost at the same time. So now all these miners will try to broadcast their block in the network along with the nonce, and as a result so a fork will be formed. So some of the block will be added in one side and the others on the other side. So there will be a competition among these two blocks, and which subchain win, that will be added in the main chain, and the other one which is discarded, that is called orphaned chain. So this chain will be discarded. And then there is a proof of stake, which is alternative to proof of work, and this is much more efficient. So in comparison with the proof of work, a proof of stake can be an efficient alternative. So in this consensus method, the miner does not need to waste a huge amount of computational resource in order to solve the mathematical puzzle. Instead, it relies on having an adequate stake in the system to participate in the block creation process. So there is another procedure which is decentralized proof of stake, or DPoS. So DPoS is an elective consensus procedure where each node with a stake in the network can delegate the validation of transaction to another node by the process of voting. So this is kind of giving the privileges of voting to any other node. And then there is another procedure which is called practical Byzantine fault tolerance, pbft. So Byzantine fault tolerance refers to reaching a consensus between two nodes communicating safely across a distributed network in the presence of malicious or misleading nodes. And practical Byzantine fault tolerance is one of the example of BFT, a replication algorithm capable of tolerating the Byzantine faults. And then the last one is the Tendermint. Tendermint is a software for securely and consistently replicating an application on many machines. So Kohn et al. Proposed Tendermint, which is based on the Byzantine consensus algorithm. So in this model, a new block is determined in each round. A proposer would be selected to broadcast an unconfirmed block in this round. Therefore, all nodes need to be known proposer selection. So the block can be divided into three steps. One is pre-vote step, and pre-commit step, and commit step. So in the pre-vote step, validators choose whether the broadcast a pre-vote for the proposed block, and in the pre-commit step, if the node has received more than 2/3 of the pre-votes on the proposed block, it broadcasts a pre-commit for that block. So we can make a comparison among different consensus algorithm, and they are made based on the three properties. So node identity management, the energy saving, and tolerated power of the adversary. So energy is one of the most concern for this proof of work algorithm, because it has recently been a huge issue, because all these procedures are so much energy consuming. And here in the table we can see a comparison among different consensus algorithm. So So we can see in terms of energy consumption, this proof of stake is good because it is low energy consuming, and some other recent methodology which is much more efficient in terms of energy consumption. And if we think about time, so that case pfbt and the Tendermint is good for time optimization. Now we'll see the applications. Blockchain has applications in various domains, including healthcare, energy industry, stock market, voting, insurance, identity management, trading, finance, and others. So blockchain has a lot of applications in healthcare, like distributed ledger technology possess the potentials to transform health services. Blockchain can be used for the traceability of drugs and patients data management, and it is also being used in energy industry. So especially the microgrid, which is localized set of electronic power source and loads integrated and management with the objective of enhancing energy production and consumption efficiencies and reliabilities. The electrical power sources can be distributed power generators and renewable energy stations. So these facilities can be created and owned by different organizations or energy providers, and they can use blockchain model to management all these resources. So blockchain can be also used for stock market. So blockchain technology could solve the issue for fragmented market systems such as interoperability, trust, and transparency. Blockchain can also be used for voting. So in US, the voting, there is a poll, and this poll suggests that only approximately a quarter of Americans feel confident that their vote is being counted, and blockchain would solve this issue by providing a distributed ledger that would ensure the votes are counted, since the ledger a voter owns is the same as the one counted in total. So this way blockchain can also be used for voting. And another application of blockchain is for identity management, because using blockchain we can allow the individuals to create an encrypted identity that does not require any username or password, while offering more security features and control over accessing their personal information. So besides, blockchain can also be implemented for trading finance. So I will be concise in describing all these applications. And so even though blockchain is a very rising and promising technology, there are a few challenges like performance and scalability, privacy, interoperability, energy consumption, fairness and security, and the current regulations problem. So there are some issues in performance and scalability, like cryptocurrency and blockchain based solutions for different business models are gaining popularity. But there is a concern regarding whether it could meet up with those increasing demand coming from different businesses and government based sectors, especially regarding the performance and the scalability. So we know so far the performance of blockchain is very slow, so that is on concern. And the privacy, so far we have known that the blockchain has good privacy. However, some researcher has suggested that the blockchain might be vulnerable in terms of transactional privacy, as the public key for initiating a transaction is visible in the network peers. So from the Deloitte's 2018 report, it can be observed that many industries are currently interested in adopting the blockchain technology, but there is no standard protocol that will allow them to collaborate and integrate with each other. So this is not much interoperable, so that is one of the limitations of blockchain now. And the energy consumption, this is a very big concern. The proof of work algorithm has enabled Bitcoin to perform transaction among peers in a trustless, distributed, decentralized environment. However, while doing this work, miner computers are consuming a huge amount of electrical energy. So this is one of the section that should be optimized. So fairness and security. Given the immaturity of this technology, there are vulnerabilities that expose user to cybercrime. Like 51% attackers are one of the most recognized blockchain security issue. So if the attacker can take control of 51% of this computational resource, then malicious entities gain majority control of blockchain hash rate is possible. So with the majority hash rate, they can reverse any transactions to perform double spending, and they can also prevent other miners from confirming any block. So that way the operation of blockchain will be stopped. And there is also a problem with regulations, like blockchain platforms such as cryptocurrencies are facing this issue. So the reason behind that is that if the blockchain is well established, then any of the government will lose control over towards the blockchain technology and their finance. So for example, many government threatened or even made cryptocurrencies illegal in their territory. Bitcoin is banned in countries such as Pakistan, Iran, Ecuador, Morocco and more, while some Bitcoin owners were arrested in Bangladesh. So future scope, the researcher believes that blockchain has immense potential in both academia and industry. So blockchain performance to lure investors by promising a huge profit. So it is compulsory to know whether this technology fits the requirement before adopting it into a business solution. And also blockchain technology allows companies to create a digital trail of record of their innovations and can generate a certificate upon registering the new inventions, proof of concepts and design that could prove the integrity, existence and ownership of any IP asset. So it is also believed that the big data analytics could be well combined with blockchain, especially in the data management and data analytics. Another emerging scope of blockchain is smart contract. According to Sejo et al., a smart contract refers to a digital transaction protocol that executes on top of the blockchain technology. So this protocol is a piece of code that is deployed on the blockchain node. So execution of the smart contract is initiated by a message embedded in the transaction, and recently various smart contract developing platforms are rising. So that is one of the most promising future scope. And then the conclusion. So in this paper, the possibilities and benefits of the blockchain along with its trade-offs are discussed through a comparative survey study, and there are still many open issues that need to be future researched and analyzed to create more workable and efficient industrial applications that can fully benefit from the use of blockchain and achieve the indicated goals. So example of this open issue including security, privacy, scalability, energy issue and integration with other systems, and more specifically with regulatory issue. And future work in this field is required to address these issues and close the gaps of more efficient, scalable and secure blockchain industrial application. So here are some references I have used, and thank you so much for watching the presentation. Feel free to ask any question if you have. Thank you so much.